In this lesson, we will be introduced to problem solving. I know how we are feeling about working with word problems, and trust me, you are not alone. But we all know how it works. The more time you spend, the better problem solver you are going to become. Here is how I recommend students approach problem solving. First, read the problem as many times as necessary to get an understanding of what is going on. After you have read the problem more than once, write down the information from the problem, drawing sketches if appropriate. What are you looking for? What is your unknown? If you're having a hard time figuring out what the unknown is, go to the author's question or the last sentence of the word problem. It can be usually found there. Define the unknown. Do this formally, meaning write it down on paper. Don't just keep it in your mind. Step 2 says for us to come up with an equation that includes the unknown, that will allow us to solve for the unknown or unknowns. And then solve this equation. And last, make sure you have answered the author's question. Include units. The sum of page numbers on facing pages is 281. We know from that statement we are going to be adding two numbers together and setting this equal to 281. Our unknowns are these two page numbers. Open up your math book anywhere. What do you know about facing pages? Their page numbers are one apart. We will use this to define our unknowns. This is a consecutive integer word problem. Recall how we set up this type of problem. X is the first page, and since the pages are one apart, x plus 1 is the second. The author said the sum is 281, so we add and set this equal to 281. Solve this. We find the left-hand page is 140 and the right-hand page is 141. And you can check by adding these two numbers together, they need to total 281. Here we are cutting a 25-foot wire into two pieces. They are not of equal lengths due to the statement regarding the longer piece. Notice how I have highlighted this statement. We are going to need to define our two unknowns, the shorter and longer piece, and we will need to do this in terms of one unknown. This statement will allow us to define the longer piece in terms of the shorter piece. Because the author is defining the longer piece in terms of the shorter, we are going to let x be the shorter piece. And how about we use s instead of x? Oftentimes we use the first letter of the unknown instead of x. This helps us keep our variables straight. Now focus on the statement in red and translate. The longer piece is 1 longer than 5 times the shorter. With our two variables defined, we are now ready to create the equation that will allow us to solve for the unknown. The author has said we started with a 25-foot wire and this was cut into two pieces. We focus on that statement, adding the two unknowns, setting this equal to 25. Solve for s and then substitute this into the expression 1 plus 5s for the length of the longer piece. As a check, these two numbers need to add to 25. Don't forget to include the units on your final answer. In this problem, the author is referring to the interior angles of a triangle. We're going to need to recall the fact that 3 interior angles add to 180. If we don't know that fact, we won't be able to solve this word problem. Oftentimes, we create an equation from the information in the problem, like the last two problems we've just done, or in this case, we need to recall a formula. Since triangles have 3 interior angles, we have 3 unknowns. Notice how we talk about the second in terms of the first, and when we talk about the third, it is also in terms of the first. With that being the case, what should we set x equal to? Instead of x, I will use f for the first angle. To define the other unknowns, we go back into the problem and translate. The second is 20 greater than the first. The third is twice the first. The sum of the 3 interior angles is 180. This gives us the equation that allows us to solve for f. F works out to be 40. The second angle is 20 plus 40, and the third is 2 times 40. This problem is similar to the last problem, but in this case, we are breaking the total length up into 3 pieces. Again, notice how the other 2 lengths are defined in terms of the first piece. We will start by defining our unknown to be the first piece and then use these statements to state the other 2. Starting with F, defined as the first piece, focus on the statements in red and translate for the length of the second and the third. The second piece is 3 times the first. The third is 2 more than 7 times the first. The sum of these 3 pieces is 46. Solving for the length of the first piece, 4 feet, substitute 4 into the expression that represents the second and the third piece for their lengths. Check to make sure that the total is 46, and include the units when you state these 3 lengths. One more problem. Here the problem talks about perimeter. The perimeter is the distance around an object, and this is known to be 195 millimeters. Since we are working with a triangle, we have 3 sides. For this problem, the 3 sides are consecutive odd integers. To set up the variables, we let x be the first. To set up the other 2 sides, we need to understand how far apart consecutive odd integers are. Does this sound familiar? We worked on defining unknowns of this nature earlier in this chapter. Adding these 3 lengths, setting them equal to the perimeter, gives us the equation to solve. With the sides defined as consecutive odd integers, we have 63, then 65, and 67 as your lengths. As a check, make sure the 3 sides add to 195, and again, include units. Word problems are not easy, especially at this level, but just like with everything, the more you do, the more comfortable and confident you are going to become. View this lesson as many times as necessary to understand the process of solving word problems. If necessary, seek some help, since we will see more word problems in the future. Thank you.